Permutations rule. When all of the items are different. The permutations rule is used when there are n different items available for selection. We must select r of them without replacement, and the sequence of the items matters. The result is the total arrangements or permutations that are possible. Remember, rearrangements of the same items are counted as different permutations. Now, when n different items are available and r of them are selected without replacement, the number of different permutations or which orders counts is given by the following. We would say, again, n different items are available where r is selected without replacement is equal to n factorial divided by n minus r factorial. So let's take a look at an example. Example 3. Permutations rule with different items. The trifecta bet. In a horse race, a trifecta bet is won by correctly selecting the horses that finish first and second and third, and you must select them in the correct order. The 144th running of the Kentucky Derby had a field of 20 horses. So how many different trifecta bets are possible? Now there are n equals 20 horses that are available, and we must select r, which is equal to 3 of them without replacement, because they're going to finish first, second, and third, meaning that r is going to equal 3. Therefore, the number of different sequences of arrangements is found as shown. Okay, we know that the value, in this case, of n is equal to 20. So therefore, the value of n is going to be 20. And we know that the value of r is 3. So what we're going to do is the following. Okay, first in a denominator, first you want to simplify that, and then we can look at the numerator. Well, 20 minus 3 is going to equal 17. That's going to give you 17 factorial. And then if you look at the numerator, you just need to write out the factorial until you get to 17 factorial, and you'll see why in a second. Well, 20 times 19 times 18 times 17 factorial. Well, 17 factorial divided by 17 factorial is going to be 1. So you don't have to write them all out, because technically you're going to be dividing it by itself. So therefore, you're going to be left with 20 times 19 times 18, which gives us 6,840. So therefore, the number of different sequences would be 6,840. Now, if a bettor randomly selects 3 of those horses for a trifecta bet, what is the probability of winning by selecting Justify to win, Good Magic to finish second, and Audible to finish third, as they did? And then do all of the different possible trifecta bets have the same chance of winning? Now ignore dead heats in which horses tie for a win. Now there are, we found in part A, 6,840 different possible arrangements of 3 horses selected from the 20 that are available. So if one of those arrangements is randomly selected, then there is a probability of 1 out of the 6,840 that the winning arrangement is selected. So the probability of one of those arrangements is randomly selected is equal to 1 over 6,840, which then gives us the scientific notation number of 1.4619 times 10 to the negative 4. It means we've got to move the decimal place to the left 4 times, which then gives us 0.0014619. Rounding that to 3 decimal places gives us 0.001. So there are 6,840 different possible trifecta bets, but not all of them have the same chance of winning, because some horses tend to be faster than the others. Because the favorite horses all finished in the top 3, a winning $2 trifecta bet in this race won only $282.80.